Hello to everyone, and welcome to this week's engineer interview with Matthew Wright. Now, my name is Scott, and I work at Primary Engineer. Before we start, I would just like to say thank you very much to signing up to this year's competition. It's our 10th birthday this year, so thank you for celebrating it with us. Now, for those of you who don't know, this is the Leaders Award competition, where we ask the question, if you were an engineer, what would you do? Pupils from the ages of 3 to 19 anywhere in the UK can join, and every single person who takes part receives a graded certificate from an engineer, just like the ones we interview. Now, we've already started to receive entries to us from classrooms across the UK, so once you've finished the project in class, make sure to send it to Primary Engineer HQ. Now, as part of these interviews, we're going to be speaking to engineers who work on loads of different projects, all of them showing the wonderful, interesting and exciting things that happen when you work in engineering. Although we do host these interviews live, you'll be able to catch them on our YouTube channel later in the week. Now, our special guest speaker is going to start by telling us a little bit about himself and what it means to be an acoustics lecturer, and then we're going to open up to the audience for questions. If you would like to ask a question, simply type it in the chat box in Teams. We unfortunately can't receive audio from the audience, so if you do have any questions, just type them in. But for now, I'm going to hand over to our wonderful special guest, Matthew.
Okay, well, hello everybody. My name is Matthew Wright. I am indeed a lecturer at the University of Southampton, so I'm about as far away from Scott as it's possible to be and still be in the UK. Maybe not quite, but that wasn't deliberate, just the way it worked out. And I'm an engineering lecturer, but I do research and as well as teaching. And there are different kinds of engineers, as I'm sure you're aware. So you might talk about mechanical engineers and computer engineers and electrical engineers and so forth. And I am an acoustical engineer, and that's rather different. And the main difference so you're probably wondering, how is an acoustical engineer different from other engineers? Well, obviously acoustical engineers are better, but we're particularly interested in, only joking, we're all good friends really, we're particularly interested in sound. And because we're interested in sound, we're also really interested in things that make sound, and one of the things that makes sound is vibration. So anytime anything vibrates, we really care about that, and that's a really important subject. Now, I came to the subject because when I was young, I was interested in music, and I absolutely still am, and I was interested in science, and I was interested in taking things apart to see how they worked, and I looked for something to study that would maybe combine those interests, and acoustics came along. In those days, there weren't music technology courses, so I did acoustical engineering, not really understanding what it meant, and to be honest, not really understanding what engineering was. But I'm very glad that I did, because I pretty soon found I was in the right place, and it was really interesting. And what I thought might have been a narrow specialized subject turned out to be an incredibly broad subject, because sound and acoustics really does touch absolutely everything that we do. So, for instance, I've got friends who are aeronautical engineers, and they care about aeroplanes and things like that. And there's a big crossover between aeronautics and acoustics, because aeroplanes are incredibly noisy things, and aeroplane companies really care about making them quieter, not just because they feel sorry for the people that they're flying over, though I'm sure they do, but because there are laws about it. You're not allowed to fly an aeroplane if it's too noisy, and those laws tend to get more strict from time to time. So there's a lot of research that needs to be done to try and make a jet engine quiet. And trying to make one of them quiet, that's a perfect example of what we call interdisciplinary engineering, where lots of different kinds of engineers have to work together. Because if you only cared about making the engine quiet, you could make it really quiet, but it wouldn't have any thrust, it wouldn't have any performance. So the aeronautical engineers and the acoustical engineers have to work together and both appreciate each other's issues. But it's not just aircraft. Obviously, every kind of transport makes some noise, but it's not just in air. The only way of communicating underwater is acoustics. Electromagnetic signals, like your mobile phone signal, they can only get through a few meters of seawater, but sound under the right conditions can get from one side of the ocean to the other. And whales use it to communicate over vast distances, and submarines do as well. And a great deal of what we know about the ocean comes from acoustical surveys. Now, the first picture that your parents saw of you was almost certainly created by sound, because that would have been an ultrasound scan that would have been done of your mum's tum with some cold jelly, sorry about that, but it's important for what we call impedance matching, to try and check that the baby's okay as early as possible. And that's another application of sound. Is you could argue that it's not sound because it's what we call ultrasound is so high pitched that we can't actually hear it. But if we understand the physics of sound, we can work out how to do useful things with that as well. So it turned out to be the most incredibly broad field, not a narrow specialism at all. But I still wanted to come back to what I was interested in musical instruments, and trying to understand how musical instruments worked. That tells us an awful lot about all sorts of interesting physics as well. So until recently, I taught a course on the acoustics of musical instruments, and one of the students who took that course is now working for Yamaha in Japan and helping them to design better violins for beginners. So it's a big field. I'll stop talking.
No, thank you very much for that, Matthew. And it's always good to sort of, because I didn't know anything about it going into this, so to sort of see how broad it can be and how many people it touches as well. We've got a few questions that have been sent in to us, and we will soon go on to the Q&A. So anybody out there who's got questions, start putting them in the chat. But I've got a question for you first, Matthew.
Sure.
What is it that you love about your job?
I suppose more and more. Well, every researcher loves finding new things and solving problems and getting the answers. You know, I love doing crossword puzzles in my spare time. My father did them and my grandfather did them before, and now I've got the habit. And you know, that sense of achievement of having answered things. But more and more, what drives me is finding better ways to explain things that I found hard to understand when I was learning the subject. If I can find, not that the people who taught me, they were doing a great job, but it's actually much harder to explain these things. And if you can find the right way and get a concept across to somebody, that's what really drives me at the moment.
I like that. That's pretty good. One of the other questions that we had was about what actually happens when you're studying under you as a professional lecturer. Is there experiments that you have the students carry out? Is there placements that they get put on? What is life like as a student at the University of Southampton?
Sure. So our students go to lectures, which are now back to being in the classroom. We had a year of doing everything online. Got to say, I really loved that, but the students weren't so happy about it. They have lectures. My lectures are what I use a teaching method called the flipped classroom, where I record videos to explain the subject and they watch them in advance. And then we spend the time in the lecture talking and asking questions and answering about it. So it's quite conversational. But yes, they have lab classes. They have the lab classes. If it was like a physics degree or a science degree, the labs would be about uncovering maybe principles and recreating famous discoveries and so forth. For an engineer, a lot of important stuff is about measurement and measuring things in standard ways. Because, for example, if you just want to know how loud it is in, say, your cafeteria or your lunchroom, then you can get an app on your phone that'll tell you fairly accurately. if you want to know how loud it is in a factory so that you can take the factory owner to court and say this is too loud, you're damaging the hearing of your employers, they are going to contest it if it was just done with an app. So there has to be a legally defined standard, and you have to be able to carry out that measurement in accordance with that standard. So a lot of the practical activities have to do with learning to make those measurements. But yeah, there are lab classes, there are chances to try out all sorts of equipment. Let me show you a bit of one of our labs.
Wow.
A chamber with no echoes. And it's a room that's about 5 meters by 5 meter cube, more or less, with these foam wedges on the walls and on the floor under that sort of trampoline springy wire floor. Can you see my mouse pointer as I point things? Yeah. So this is a couple of our students, and he is setting up a microphone on a stand here. And this is a special speaker with, well, it's sort of multiple speaker with lots of different speakers. And we're very interested at the moment in trying to create sound fields that sound as though the sound is coming from somewhere else. So the stereo system on your gaming console or your TV, where the sounds could seem to come from behind you, even though the speakers are in front of you. We're trying to do sort of ventriloquism like that. So she is setting that up. And the point about these foam wedges is that any sound that is radiated away from that will not reflect. If you clap your hands in a room like this, you're always going to hear a bit of echo from the walls. It might not sound like a distinct echo, but it will be there, and it makes a difference. This, the sound just goes away and comes back, and it's quite strange when people come and visit and show round, and I show them round. I ask them to stand in pairs and talk to each other, and then slowly turn around on the spot. And when they're facing away, you can hardly hear them, whereas it would in a room, because what you're hearing then is the echoes.
So with those, so they foam, did you say? Almost
That's
those,
right.
yeah,
That's right. They sort of partly absorb. They absorb the sound, and they're organised so that a sound wave coming in, it'll bounce around between them and get multiple reflections, and a little bit more is absorbed each time.
And why are they that shape? Do they have to be pointy like that?
Well, it's to make them so that any sound coming in bounces off but doesn't bounce straight back. If it was just a flat sheet of foam, then we get quite a bit of reflection, because that's just one reflection. Because they bounce back and forth between the wedges, you get multiple reflections, and there's a bit more sound absorbed each time.
Fascinating. Well, we've learned a little bit about what happens at the university and a bit about yourself. So anybody out there, if you're sitting on any questions, please type them in using Microsoft Teams. But this is a question that was sent in to us. Matthew, do you play instruments as well as being an engineer?
Yes, I absolutely do. I learned piano and violin as a child. Unfortunately, I've got a genetic condition, which means that nowadays I'm a wheelchair user, and I haven't actually got much strength in my right hand, so I can't play my violin anymore, which is a great shame. But I've found a way to play other instruments, and that's made me explore other instruments. And I've got an instrument here actually that I use in my lectures, because it illustrates all sorts of things to do with sound waves and pipes. So this is basically just a long tube. I don't know how well you can see it, but it hasn't got any holes in it. And at one end, it's got a recorder mouthpiece like that. So if I point that towards the my microphone and try and play something on it, and you can actually play almost a tune if you stick your finger in the end. And that series of notes that you heard it playing as I blew hard, you get the same thing if you've got any string players. You can get the same thing on strings. It's called the harmonic series, and it's really important for lots of things to do with acoustics.
Well, it's good that you still play instruments, because you did say that's what you were really interested in when you first started out as well, back in school.
Well, I actually play the concertina for my local Morris dancers as well. I've got an adapted one-handed concertina. I should say I'm also trustee of a charity called the One-Handed Musical Instrument Trust. And if you know any other one-handed musicians, please put them in touch with them, because they have out things like one-handed recorders, so that if you can only play with one hand, you can still get involved in music making.
That's brilliant. We can share that link with everybody as well, just so that if anybody out there knows someone, they can point them in that direction. So we've got some questions coming in. This question comes from P Senior, and they ask, how do you know how to build something like the echo room?
That anechoic chamber, yeah, it was. Let me just put the picture back of it. If I had to design that now and I didn't know how to do it, and if that had never been done before and I was trying to do it for the first time, almost certainly the first thing I would do is make a computer model of it and then adjust the computer model until I got the results that I wanted. And that's how we do an awful lot of design these days. But anechoic chambers were actually invented in the last century by, I'm trying to remember, I'm not sure, certainly a very famous acoustical engineer or acoustician called Leo Beranek in the United States. He did a lot of the early work on developing it. I'm not sure if he was the first person to develop one, but he kind of worked it out from first principles and a lot of trial and error and experiment. But with a chamber like this, the thing is, it's pretty easy to absorb high frequency noise. If you just put foam on your walls, then, or if you just got thick curtains, then high frequencies won't be reflected, but low frequencies will be, and that's because of something called wavelength. So remember how, as I blew harder on the pipe, the notes went up higher frequency, and that meant that more waves, more shorter waves, were fitting in the same distance, and that's why it went up in steps. And the longer waves, they're harder to absorb, so you need longer wedges. So this isn't the only anechoic chamber that we've got at Southampton, but it's the biggest, and it's also the one that absorbs down to the lowest frequency, about 9. We measure frequency in hertz. A hertz is 1 vibration a second, so 90 hertz this can just about go down to, whereas most anechoic chambers can only go down to a few hundred hertz.
This question comes from Gia, and Gia asks, what's your most successful project?
I would have to say, and this is going to sound smarmy, but my most successful project is teaching, because the students that I do, they go on to do such exciting things. And I don't know all the things they do, because they don't always write back to me. And of course, they're not my students, they're our students, because it's not just me teaching them, it's a whole team effort and things. And lots of engineering projects, particularly the bigger ones, you don't necessarily see them all the way, you're not necessarily involved all the way from start to finish. So I could give you a long list of projects that did some really interesting things but didn't quite make it into the project line. And some of the projects, if they were working closely with companies, I'm not allowed to talk about either. Because a lot of acoustical engineers are employed as sound designers by companies. The sound of a car, for instance, sound of a racing car, well, not a racing car, but a high performance car, that doesn't just sound the way the engine came out. There are people employed to design the sound and make it sound like the company want it to sound. So each company has a particular sound. So they are designed just in the same way as the clunk of the door when you close it is a designed sound. But companies don't particularly like to boast about doing this. They prefer to keep it quiet.
That is quite cool that Ferrari have their own engine noise that's been very cleverly sound designed.
Well, they have. It's a kind of like a brand thing. They have a. They don't want their cars to sound like someone else's cars on the track.
So we've got some more questions in. This one comes from Joanna, and Joanna asks, what skills do you need to become an engineer?
Well, The usual answer to this is you need to be good at maths, and you do, and you need to be good at science, and you do. But really, the one message I always want to get across, because I don't go to so many schools nowadays, but I used to go to a lot of schools, careers days and events, and talk about this. And what I really try to fight against is the idea of, okay, you're a technical person, so you be an engineer. You're a people person, you be a teacher. Not that there's anything wrong with being a teacher, absolutely. But, or you're a people person, you work in a hotel, etc. Engineering ultimately has always got to be about people. An engineer is a person who uses technology to make the world better for people. And if we forget about the people, then we're just playing with ourselves.
I like that answer. We do, and we've got some more questions about yourself, actually, Matthew. Who or what was it that inspired you to think you wanted to become an engineer? Is there a person or a moment? You mentioned really being into music and also breaking things and seeing how they worked, but is there a sort of person you remember or a moment you remember going, I'm going to be an engineer?
Not so much a single moment. It kind of crept up on me. I turned up at this acoustical engineering degree course, met a lot of friends, some of whom I'm still in touch with today, and some of whom are far more successful than me in all sorts of fields. But I really started off with the mindset, well, let's see what I can learn that will satisfy my interest in music, and I thought sound recording and stuff like that. I didn't understand the difference between a sound engineer and an acoustical engineer. And it crept up on me, and I found that by the time I was a couple of years into the course, I was starting to think about a research project, because all our students do a research project in their third year, that actually this is what suits me. And I see it happening to our students ever since as well, you know. Something happens and they start thinking like engineers.
So there could be a moment that's coming up for some of the viewers of this that goes, maybe this is for me.
Yeah, but it's also it can be a gradual thing as well, and you don't necessarily notice it happening. It's not always a lightning bolt transformation.
Well, we've got more questions coming in. This one again comes from Joanna Merkel, and it is, what happens when you break the sound barrier?
I had a picture about that and I haven't got it ready. That's annoying, and I don't think I'll waste too much time. I really should have got that one ready. What happens is, if you think about when a fire engine or an ambulance goes past with their siren going, and it goes, and as it goes past, it seems to go, it seems to go lower in pitch and then higher. Or if you go to see racing cars, if you're at a racetrack and you hear a car go past very fast, it goes, and that drop in pitch, high to low, that's something called the Doppler effect, because the sound waves being emitted by the moving car, because it's moving towards you, they're closer together in front of the car than behind. If you imagine little circles growing out of the car as it moves along. I really wish I had got a moving picture for that. Maybe there's a way to share it afterwards. I'll see if I can pass on a link afterwards. And they get crowded together. When you get to the sound barrier, when you're going exactly as fast as the sound, all those pressure waves, the sound going directly ahead of you, that has nowhere to go. And sound is pressure waves. It's tiny little pressure waves most of the time. But if they keep building up and they don't have anywhere to go, they get bigger and bigger, and they can exert really considerable forces. And once you're going faster, it's kind of everything's changed. And now there's no sound emitted ahead of you. It's only coming behind you. So if a plane is flying towards you at supersonic speeds, you don't hear it until after it's been passed.
That's pretty good. If you do find that picture, we can share it with everybody out there as well, and we'll make sure we put that in the recording too. We've got some more questions coming in. This one is from Elizabeth Thomas, and Elizabeth asks, what degree did you need for your job, and do you still have to train?
Yes, I had to train. My job is kind of not going out and getting a job, because I pretty much stayed at the university where I did my degree. And before I did that, I did another degree, a PhD, a doctorate. And so, and to be a academic these days, you do need a PhD pretty much required. Though back in the days, one of my professors, when I was a student, one of the most senior professors in the department, he didn't have a PhD, but he did have 2 degrees, one in maths and one in music. But things are slightly different nowadays. So yes, I had to do a PhD. Back when I started teaching a long time ago, I was given a bit of training, but really not enough. And I'm very glad to see that nowadays that's taken much more seriously, and new lecturers get a lot more attention, because I know that when I started being a lecturer, I was absolutely dreadful. It's really kind of embarrassing, but you know, I decided that because I thought that I understood stuff better than when I was a student, that clearly I just had to tell them how I felt now and they would understand it too, and it doesn't work like that. And then I got cross with them when they didn't understand things as well as I was just really bad at it. And I gradually learnt by mistake, and I had a lot of help from friends. But I'm glad that lecturers nowadays don't have to go through that.
So we've got time for a few more questions. So if anyone out there is sitting on a question, please send them in. But this one comes from Jacob, and Jacob asks, have you travelled far with work? You mentioned about being guest lecturers. Does that mean going other places?
Yeah, there's regular acoustics conferences in different countries. There's an organisation called the Acoustic Society of America, of which I'm a member, which has regular meetings. I don't travel so much these days, partly because I'm a wheelchair user and it's kind of hard to, it's not impossible, but it's a bit of extra effort. Partly because I am much more concerned about the environmental impact of flying and try to reduce that now. But yes, absolutely. There can be a lot of travelling involved in it, and a colleague of mine is really interested in the sounds that whales make. So he processes the signals that are recorded in them. So students who do projects with him have to go off to places like Madagascar or wherever and spend time on a boat dangling hydrophones into the water to record the sound of whales making sounds. So obviously that's a very hard life for them, but they seem to manage okay.
Yeah, that would involve a bit of travelling if you've got to go where the whales go. So this question comes from Horton Grange. What was the first instrument that you played?
I started having piano lessons when I think I was either 7 or 8. I think my father gave me 10 pence to go to my first piano lesson. He bribed me, and it worked.
And it worked, yeah.
Not sure I ever paid him back.
Okay, well, I think we've got time for one final question, and this is a question that was sent in to us. Are there new inventions coming out of universities that are going to change the world?
Absolutely. Lots and lots of them. I mentioned the virtual stereo. There are lots of people working on trying to make sound images better. But a colleague of mine has also found a way of combining. Remember, I talked about ultrasound, very high frequency sound, with very small bubbles. Bubbles are really interesting in acoustics for all sorts of reasons that I guess I don't have time to go into now. But he's found a way of making cleaning processes work at low temperatures with no detergent by combining ultrasound and bubbles, and the environmental implications of that could be very significant indeed.
Wow. Well, I think thinking about the future, I think that's a good time to bring this all to an end. I want to say thank you very much to everyone out there for joining us, but a massive thank you to Matthew for helping inspire all the engineers in the making out there. Because now it is your turn to come up with your own engineering ideas. Remember and send them to us once you've got them designed in your class, and we can get your certificate sent out to you before hopefully seeing you at the public exhibitions at the end of the school year. Don't forget as well that this interview will be recorded and uploaded to YouTube, so you can watch it again or share it with fellow teachers. Just search for Primary Engineer and you'll find it there. But for now, I want to say a massive thanks again to Matthew. And remember, if you were an engineer, what would you do? Thanks so much, everyone.